Hi, and welcome to another Rigonomicon video. Today we're going to be transferring a character from Maya, and we're going to be bringing it into Unreal 5 in particular. It's a little different than Unreal 4, but just know that Unreal 5 is actually more complicated. Unreal 4 is more forgiving. But Unreal 5 has become pretty much the new gold standard, and even if you're not a video game animator, this is a skill that will come in handy for you, because little by little, real-time methods are finding their way onto movie sets, and it might be a good idea to understand at least how it works. Also, if you're rendering stuff, Unreal is great for making videos because it has a lot of neat, really up-to-date features for rendering. So, all right, so we've got this character that we put together in Maya from previous videos. All we really need to know is that everything's been named, and the structure of the skeleton is following the same rules that we've established through the golden rules. Please, if you haven't looked at it, I suggest very strongly to go to the Rigonomicon.com and specifically look under the golden rules. Those golden rules are all explained as to why we do what we do with those golden rules. And sure enough, the people at Unreal or at Epic decided to do exactly the same thing. It seems like we all kind of come to the same conclusions, and we all use the same kind of best practices. Okay, so this skeleton has been set up pretty much like it is in any Unreal. Unreal 4 skeleton. Now here's a nice little touch. Even though we're going to be exporting this to Unreal 5, we're still going to be compatible because Unreal 5, their new skeleton that they've created and new characters, well, they call them skeletons and rigs. They're going to be compatible with what we're doing here, even though this is technically the Unreal 4 skeleton setup, and that's okay. These days, it doesn't have to be exactly the same skeleton. It will find its way by the naming convention, and since we're consistent and we named everything correctly and aligned all of our bones exactly the same way, like I said with the golden rules, we're good to go. Okay, so now would be a good time to open up Unreal. And so while we're getting that going, I'm going to open this up. Okay, so what you want to do is, there's a lot of stuff for purchasing and so on, but the most important thing for us is going to be the library, where we have the different versions of Unreal, and also you're going to notice I have a lot of things that I can install. Now these things, little by little, every month I would log in and check what's free, because every month they have a new set of things that are free, and I strongly suggest getting your account up and running with Unreal and start getting those free assets. You never know when they're going to come in handy. I've used a few of them already. Little bits and pieces, never an asset straight, just like that out of the box. It's rare. There's always optimization and things to do. So I've downloaded the latest. I suggest you do the same. Just download whatever and just launch it. All right. So while that's getting started, because it's a little slow on the first run. So here we have the splash screen. It's going. It's probably going to go through some shaders. It might take some time on yours if you haven't even run the editor yet. So just know that. And while we're doing that, I'm going to talk about my, I guess the best word I can use for this is caveats. Things that we need to take into consideration when bringing into Unreal. Oh, okay. So we can go ahead and click on the game section. And the reason why we're going to click on the game section is because we're going to use the third-person game that they have here. Like, it's a demo of the third person, and build on top of it. Basically, what we're going to do is replace the character that's walking around, and we're going to put in our own stormtrooper into the level. Now, the skinning is going to be a little bit rough, but that's not important. But this is going to give us a good idea if we did a good job and if we're compatible with all the stuff that's built into Unreal. So the first thing we're going to do is just set it to blueprint. We're going to leave it on desktop. Quality is going to be maximum. We're not going to need the starter content because we already have the main thing that we want, which is just being able to run around in third person with an Xbox controller or mouse and keyboard. We're not going to use the ray tracing because you may not have an RTX card. And one of the things that's always handy is to prepare a like right now I'm in Windows 11, so I'm able to have tabs. But I strongly suggest always doing this when you're about to start any project is get your folders ready and have them handy. So at any moment you can just switch back to your Explorer and copy the path. So this is important because this will save you a lot of time. So right now, the only two folders that we're going to need for today is going to be the one where we're going to export stuff and the one where the actual project from Unreal is going to live. So if I look here, I'm going to copy this. So this is going to be the folder where it's going to go. And now I'm going to go back to Unreal, and I'm just going to do this. And what we've done, what I've done here is I just need this part. That's going to be the name of the project, and that's going to be the folder. So I've got my folder where I put all my projects for Unreal, where I'm testing stuff, and then Maya to Unreal 5. That describes what we're doing today. And then I'm just going to go create. And it's going to create a whole new project, and it's going to be super lightweight. If you ever do any outsourcing for somebody, this is a good way to package things quickly so they can see the assets. What you do is you make sure that you minimize what is in the level, and that could, I've done this before with certain clients. I send them a Google Drive type of link, and it will contain maybe a little project that's an Unreal project that you can launch, and you can see the assets in real time, and they can just copy those and migrate them, as they say, to, that's the term we use to transfer from one Unreal project to another. And this will create, in this case, we've created an actual level. Well, it did it for us, but we're going to press the play button. And I'm actually going to switch to my Xbox controller while clicking. I have to click on the screen first. You can change that if ever that becomes annoying. And you're going to notice that it's analog. So if you do a soft, it's like you just push the stick slowly. It'll bring in its animations for the character, for a walk, and if you do a hard press, you can do a run. And if I'm not mistaken, there's also a sprint you can set up. So we have a character that can run around. And what we're going to do is we're going to replace the skin so that it is compatible and works with this character. So that's great. Now, the only thing we need to know at this point is where the blueprint for that character is. Now, a blueprint is basically, think of it like a package, like a box, where you put stuff in. You put in the mesh, you put in the logic on how it moves, you put in everything that's related to that character. And you're going to find that if you look into the content folder. If you can't see it, there's usually one down here, and you can pull it up. But I prefer having it like a folder like this. I find this kind of layout works a little better. And but you should be able to move things around to your liking. So in the case of level prototyping, so we got this third person. Here we go, blueprints. This is what we want. We want to find something called the third person character blueprint. You can see it says blueprint class. You can find it other ways. Like if you want to, you can click on the content folder and click on here to get a filter and say, I want to see all blueprints. And it will show you everything that's in the folders related to blueprints. The third-person game mode has to do with how the controller works and stuff like that. But then the player itself and what to do with the inputs will be here. And I'm gonna take half the screen for this guy, and I'm gonna disconnect this. So because I'm working on one screen, and that's a little bit tough with Unreal. So I'm gonna try to do the best I can. If hopefully you are doing this with two screens, and it's going a little better for you. So this is the blueprint that we loaded. I know it looks like a lot of stuff, but you don't need to worry. We're not going to be playing around with much of it. The only thing we need to care about is what's over here on the left side, where we see what the blueprint is made of. Remember, like I said, it's like a box with stuff in it. And one of the things is the mesh, and it's telling us that the mesh is right here. So I can click on this little magnifying glass, and it will go and find where this mesh is located, and it's right here. So this is the skeletal mesh that is being used when you play the game or run the game. So we want to make sure, I'm going to double click it now, and it's going to show me what that asset is. and it's going to all things that I click on will be here. All things related to finding folders and such will be on the right side. So hopefully you can see what's going on very clearly. Now, one of the things that's important here is you're going to notice that if you're used to Maya's controls, this is pretty much the same. You can do the same thing that you normally do in Maya. It's the same hotkeys. One thing that's interesting is if you go to the character bones section, you can say, I want to see the whole hierarchy. And now we can actually see that the bones are how they're named, what direction they're pointing, and so on. And you're going to see that there's a hierarchy here. Now, I clicked on the skeletal mesh. In Unreal terms, that means the vertices that compose the mesh plus the skin weights that attach to the bones. But the bones themselves are separate, so that we can share the same skeleton with all of the other characters. So if you click on, you'll notice up here, there's kind of like think of it like a progress. Like you need to have the skeleton first, and this is just the skeleton. And this is a separate asset. It's not this skeletal mesh. It should, like if you're having trouble finding it, you just click on the little magnifying glass, boop, and it's going to show you that it's over here. This is a separate object altogether. And it contains all the information about all the bones that are in this skeleton. Now, the important thing here too is that you have a list that has names that are in dark gray, meaning the base skeleton does not have these, but there's something that uses this base skeleton that requires it. So it needs to keep track of which bones have been added to anything that uses the base skeleton. So you're going to notice one of the main ones here, the most important ones are right here. It's going to tell you the center of mass, the IK foot, the left foot for IK, and the right foot for IK. These are going to be things that we absolutely need to take care of in the near future. So we will just keep this in mind for now. One thing I am going to do is I'm going to go back to my folders. Let's see, folders. So I'm going to go over here. I'm going to close this one to make it easier to find stuff. So in this folder is where we're going to be exporting stuff. So I'm going to also export the Unreal skeleton so we can take a look at it. And I'm going to just take, let's say, this one right here, the one that we saw was being referenced. If you right-click it, you should be able to go to Asset Actions, and there's going to be an export. This will basically pull out the skeleton and the mesh and the skin weights of this model and turn it into an FBX that we can load up in Maya. So I'm just going to paste my folder here, and it's going to name it correctly and everything, and I'm just going to go save. You're going to notice that like for the most part, this doesn't matter so much as long as the default should be fine. You're going to notice it's going to use the 2013 FBX file format, and that's a really old one, but the reason for it is because in this case, it's going to be more than enough to get the data so that it's in a compatible format in Maya or whatever software we're using. So I'm going to export that. So we've done all the work on this end. Now what we need to do is see if we can get our character into the game from Maya. So let's go back to Maya. And here's our character. And what we're going to do is we're going to do the dummy approach to doing this. So what I was mentioning before about caveats in Maya is one thing you have to consider. And before I even export this, just keep this in mind. The Maya up vector is Y. And in Unreal, you're going to notice that it is a Z axis up. Okay, so not every DCC uses the same up direction and something that we call left hand and right hand. That has to do with when two axes point in a certain direction, where does the third one point? And if you use your right hand to determine this, it points in one direction. And if you use your left hand, it points in the opposite direction. All you need to know about that is that can affect rotations. And you need to have something that can convert these things. For the most part, the FBX exporter will deal with that kind of stuff, but the up vector is not something that it deals with very well. So in the case of Unreal, it's Z up. I'll just go over this really, really quickly. The reason why there's a difference in this particular case is that Maya is more based on what you find in textbooks. So when you're in a textbook, the Y is up and the X is to the right. That's how you graph things. And they made it so that's the front view, so that's up. and that's to the right, and that's X and Y. But the what we have in Unreal is based more on software that is more akin to floor plans, because after all, you're building games that have levels, so it's kind of like building a floor plan. And if you've ever used AutoCAD or 3D Studio Max, which is built around floor plans, we use ZUp because the X and Y is basically looking at the floor from the top. So we're looking at things this way to build our levels. We're not looking at it from the front like this, like you do in a math textbook. So that's the difference between the two. And just know that this is now going to be an issue. And I'm going to export it so you can see what the issue is. Because here we've made our root node for this character. I'm going to activate its local access. You're going to notice that it's, in this case, it's ZUp, but, okay. So this has already been fixed. So what I'm going to do, I'm going to open a version that has not been fixed. There we go. I want to make sure it's broken so we can see what kind of, because you're going to hit this problem if you didn't fix it. Here we go. All right. And I don't like doing sneaky things where I fix things in the background and redo the video or cut the video. I'm going to try to leave everything as is, because there's more value to you, because if I hit the problems, you might hit them too, and I'm going to show you the approach on how to solve those problems. So in this case, I want to make sure that it is aligned the same way that Maya aligns bones, even though the rest of the skeleton has been aligned with the Unreal methods of alignment for bones. If you remember, I'll just go over it briefly. X points to the child node. Z points in the direction where the first thing that you're going to animate is going to be basically this is the axis where you're going to animate first. In the case of let's say an elbow like this, I'm going to definitely do this type of thing for an elbow. So that would be, you have to make sure that the Z axis points in that direction. Okay, so I'm just going to export this. And all we have is our skeleton, with the root being the one at the top, hopefully. And then we have two meshes with skin on them. That's it. This is great. One other thing. If you're using Maya, one good way of separating your files is by using references. So what we use as a skeletal mesh in Unreal, which is basically the skeleton with the mesh and the skin weights, could be a file that you then reference for your rig and where your animation lives. So you can separate the two, and you make it much easier for yourself to be able to export. If all of that is gibberish to you, no worries. What you do is, after you've set up your rig on your character, make sure that you simplify what gets exported so it only exports what you're seeing right now, which is basically any joint that has an influence over vertices. Okay, so we're going to export this. And I'm going to use the default settings, export all. And let's see, do I still have the, yes, I do. So here's where we exported. Remember, we were in Unreal, and I exported the SKM Quinn Simple, but basically the thing that it's using for the game. So I'm going to use a similar format. SKM stands for skeletal mesh. So SKM Storm Trooper. And I'm going to look just over here to our options. Make sure your files of type is set to FBX export. And you should have the same thing that I do here for options. We're going to go over them really quickly. Smoothing groups need to be on. We're not going to split per vertex normals, because that's going to create a lot of issues. Tangents and binormals, I strongly recommend you use that, especially if you want your normal maps later to match up correctly with your normals. Smooth mesh, if there's a smooth mesh, I export it so that it understands that. Selection sets we don't need. Convert to null objects, no. Preserve instances, we don't need to do that. Unreal will handle that really well. Reference assets content. In this case, that doesn't matter. Unreal's not going to know what that is anyways, and it'll just ignore it. We're not triangulating. and convert NURB surfaces to, well, we're not using NURB, so it doesn't matter. But if you did, I would strongly suggest removing that. For animation, we're going to keep that on, even though there's no animation in the scene. But if we do export animation later at a later date, it will still, our export will still work. Use scene name, no. Remove single keys, we don't need any of that. Quaternion interpolation mode, leave that to the default. The FBX format is not my favorite format, but it basically, whenever you touch something, walk away slowly and hope it works. Bake animation, this is important. One of the key differences between working in Maya and working in basically any engine is that your constraints, your IK, all of that stuff, most often does not come with the FBX. So you need to convert that into keys for it to understand. So this is quite common that we always have that kind of thing. And make sure your skins and blend shapes are added. When blend shapes are exported, the mesh itself should be included as a bone. I won't go into it too much right now, but just know that make sure you have that on. And for the most part, everything else, just leave it on default. And here's something that's important: scale factor 1. So I haven't mentioned this yet, but FBX is kind of the exporter, the thing that exports in basically any Autodesk software. The kindest way I can put it is it always uses the path of least resistance, or basically the easiest thing it can do instead of the thing that you need it to do. So whoever wrote the exporter for all Autodesk products has kind of made it so that it's not really all that useful to us when we're dealing with engines, because we need to convert the values so that it doesn't add nodes with scales and rotations. So for example, to fix a scale, if you say that it's not 1, if you don't want it to, because we're going to be dealing with that in just a moment, as you can, you'll see in a second. But scaling factor here is going to be something that we want to solve, but we're not going to use the thing that's inside this exporter, because it's not going to solve it in a way that is useful. It's going to create an extra node. It's going to put that as the root, meaning your hierarchy is completely different now, no longer compatible. And it's going to add a scale factor to it, meaning it's going to introduce scaling. And if you've been following along with other videos I've made, we know that scaling is something to be, if you use it, you have to be very delicate with it and make sure you're not creating so many problems that you eventually just have to scrap what you're doing. Scaling is a quick path to full destruction of what you're doing. I'm not exaggerating. So we have to be very careful with scales and not introduce them in that way. A better way to scale things is to actually change the actual values of positions. And we'll go over that in just a moment. Just keep that in mind, that there is a thing here. And also the axis conversion, it's the same idea. Leave it with the default. The up axis will be Y. And we're going to need to make sure that we're not introducing any extra nodes that have been rotated on the X axis. What I mean by that is the Z axis is what we want to point up in Unreal. And in Maya, it's the Y axis that points up. And one of the solutions to that is to rotate -90 on the X and add a node to your entire structure. But then again, you're adding another node to your structure, and that gets messy. Okay, all this just to say, for the most part, you should be okay unless you touch some of this. By default, it should be okay. So we're just going to export it. Now I'm going to bring it into Unreal, and I'm going to look over here, and I'm going to do this kind of thing. I'm going to get rid of the preview. I'm going to move this so we can see it clearly, but when I click on here, it's probably going to disappear. So what I want to do is, first of all, just determine a folder where we're going to bring all of our stuff in. So this is where we're right now in mannequins, and that's different from mannequins UE4. So Unreal 5 still maintains all of the Unreal 4 stuff, and created a new folder called mannequins. And in the past, we used to call it just the UE4 mannequin, and now they felt clever, so they split the normal mannequin into two. One's called Manny, and the other one's called Quinn. So Manny Quinn. and one's a male character and one's a female character. My cat, he wants attention, but right now we're doing a video. Sorry, buddy. It's okay. All right, so yeah, so what we're gonna do is we're because the video, like the demo that we have here that can play a character is the female character. We're gonna be focusing on the female character. And even though our character that's coming in is going to be male, this is just to show how we bring it in and we make it compatible. And actually, that can work. It's just that our stormtrooper will have the feminine animations. Wow, you really want attention, eh, buddy? Okay. Hang on a second. My cat's getting comfy. This is what you expect from Rigonomicon.com. All right, so now that we've looked at this, we're going to create that folder that we need. I'm going to create it right in here. I'm going to right click and I'm going to go new folder. Oh, and I'm going to say, Storm Trooper. It's not easy with a cat. All right, so I'm going to go into that folder. Now we're in this folder. That's a subfolder of where the mannequins are. And I'm going to bring back our Explorer. And we created the SKM Stormtrooper. And that means that we can drag and drop that in directly here. Okay. And this little window is going to pop up. We're going to go through this. It's nothing complicated. We want the skeletal mesh and the mesh itself. So that means skeleton and mesh with skin weights and all that. For the skeleton, we're going to actually use as a base the one that says SK mannequin skeleton. This is confusing and I wish they'd rename this, but the SK mannequin skeleton is the skeleton. Remember this thing over here? There's the skeleton, there's the mesh, there's animations, and then there's all kinds of blueprints and stuff. This is the one from Unreal 4. And you can even see it when I scroll over. You can see the little pop-up text that's showing up in that box. It's showing the tooltip is saying that it's UE4. It's from the UE4. And if I just hover over this one, it's going to say it's from the mannequin meshes. Because our skeleton that we created is from the Unreal 4 setup, we're going to click on the one that's for Unreal 4. So it's going to share. If you don't do that, it'll just generate a new skeleton. That's not necessarily bad in this case. Unreal 5 is much more forgiving than Unreal 4 was. But just using this, we're gonna be in a better place because it should be compatible with that. Okay, so we're not gonna import animation because it detected there wasn't any. Let's see over here. This is important. Convert scene. Yes, it's gonna deal with the Y and the Z. We're not gonna. There's not much in the advanced. Search locations for materials. We're going to say do not search. Material import method. We're not going to create new materials. We're going to make that ourselves, and we're not importing our textures. Then in the advanced, there's nothing here that we need to worry about. Although there's something there that it's not important. That'll be a pop-up later that it will show up. So with that in mind, let's import it. And if we were good in Maya, we shouldn't have any issues, and it's going to use the skeleton. So if I double click this, it's going to show us our character, but you're going to notice something bizarre about it. These joints are really big circular joints. So we're going to keep that in mind as we're doing this. And I'm just going to go back to my third-person character blueprint. Remember we had the mesh here selected, and that's how we were able to find the skeletal mesh. I'm going to make this that's currently selected and I'm going to replace the one that's in here by clicking on that little arrow right next to it, and it's going to basically apply that that's in the content browser, and it's going to apply it onto the skeleton here. Now, and this is going to be easy with a cat, I'm going to press F11 maybe to make it a little bit bigger. There we go. It's a little bit better. So we've got problems. This doesn't look like what we had, right? So the first problem we have is, well, the character is really tiny, and it's doing almost like a fly swatter. It just when I push forward, it just kind of goes blap, and it's floating up in the air. So let's see what's going on here. If I go into this mesh, And let's say I know that there's a 10:1 ratio scale issue, and I set this to 10 for the scale of the object. So that means the mesh that we exported is being brought in, and then it has its own transform of where it is. If ever you're wondering what this is, just click on the viewport here, and it's going to show you what's going on with your character. In this case, it's pretty bad. So it's floating up in the air, and it's not very helpful. But this is just showing us kind of like a preview of what that character is. And if I click now, you should. It's still about the same. Although my cat's not making this easy. If I move forward now, there you go. It goes and flies downward. And this is really messed up, right? So I'm going to go over what all the problems are, and I'll explain why this is happening. And we're going to go through each issue and solve them one by one. Okay, so the first thing that we need to understand is scales in Maya. Scales in Maya is a big issue. Like I mentioned before, Maya's Y direction is based on textbooks. So a lot of times our values that are here are they're almost designed to be textbook values. Easy numbers to understand and have it so that when we click on something like, for example, the translate X, and I middle click into the viewport, you'll see that the values, the thing that changes the values is going in a nice increment. Even though you have increment controls like up here, like this little blue circular thing, is controlling how fast these increments are. So you can have it very sensitive. My cat's not having it. Okay, sorry, buddy. And you can have it so it's less sensitive to the point where it's pretty fast at this point. And why am I showing you this is because of how everything has been scaled by default and what Maya considers to be a comfortable scale for things to work. Unfortunately, comfortable scale does not equal proper architectural and level design measurements. So Unreal uses centimeters because it's a good way of calculating the scale of a thing. And because it's in centimeters, we can easily convert, for when we're dealing with large maps, we can easily convert those values into kilometers. And those numbers are easy to read. In a scene like this one, this character is designed to be like let me just turn on. Okay, so I've got my history, and I'm saying that because I need to create a box. And this box, I want to be able to change its values. And if I didn't have history on, that would not be there. It would be a collapsed mesh. So height, I'm going to keep moving this. You'll see that this spinner is happily moving along. The height right now is set to 37. And because it's going both, so let's say 40 is the closest round number. That means that the character's height is approximately 20. I want you to think about that number for a second. What the heck is 20 for a height of a character? And I built this scene so that it respects Maya's numbers, because everything from IK to even modeling and making changes will be affected if your mesh is too big or too small. You're gonna feel very uncomfortable inside of Maya if the minute that you start just sliding around, moving things, you're gonna feel it right away. It doesn't feel right. So generally in Maya, I find that we often have these scales set to what I would consider, what I would call the decimeter, because 100 is too much and 1 is too little. They went somewhere in between, so they went to a scale of 10, and a character is approximately 2 meters in height, just under 2. Like that's I'm not joking. Basically this character is 180 centimeters high, which means it's 18. The actual measurement is 18 in decimeters. Yeah. Okay, so this is one of those things where you go, okay, well, we're a special butterfly inside of Maya, but we need to get this to work in other systems. So the first thing that you're going to need to do is, unfortunately, let go of the Maya favorite scale size and start using centimeters. So we're going to need to convert this character so that it fits in centimeters. And the other thing that's very important is we're also going to need to fix the Y up so that the root node is Z up. And once we fix those two things, it'll be great. Now, the first thing that you're probably going to be thinking about is, how do I make a character bigger without using scale? Because we've established that using a scale is a bad thing and can cause trouble. In fact, I'm going to save you a lot of headaches. If you use a scale, I'm going to save you the time and the headache of this. If you brought that into Unreal, it still wouldn't fix the problem, and you'd be going around in circles trying to figure out how to get it to work. In Unreal 4, it would have worked if you used the that method that I just showed you inside of Unreal, where I set the scale here to something that is 10, a scale of 10. So let me see. It seems like it's almost like 100 in this case. But it's seriously going too high. No, it's definitely a scale factor of 10, as is standard with Maya. So if I look down here, my mesh is definitely, yeah. We're going to need to fix this. This is a 10:1 issue again. So I'm going to leave it at scale of 1, and we're going to bring in a new mesh that fixes all these problems. Let's head on into Maya, and let's see how we can fix this without doing any scaling. Because you're going to notice that even if you try to scale it here, let's say I go try to set this to 10, it will not work correctly because Maya's joint system has something that counters any scaling. So it's designed specifically to avoid scaling issues. But if these were just normal objects, they would scale correctly. But these are joints, so not the same thing. Okay, so how do we fix this? Okay, so one of the new buttons that I've added, and let's, like I said, make sure you're in version 0.3.2 alpha of the Rignomicon tools, because I've added a new button for hierarchies. So, for example, if I select this bone and I say I want all of the sub bones, if I use this tool and go select hierarchy, it kind of seems like it worked. Problem is you can only do it one at a time. And also, if there were shapes, it would select the shapes, which is bad. I just want things that have transforms. So you can right click here and go select children, and it will give you the same result right now, but also you can just press the button. It's a lot faster too. And it will do that, but I've also added a couple of other things for manipulating hierarchies. So we're going to scale hierarchy by translation. What the heck is this? All right, so it's got a little window that pops up, and I've already, for the most part, you're always going to be doing the scale of 10. So if I select the root node and I click this button, it's going to move all the bones in the correct place and change even the radius of my joints so that they look right. But obviously this is not what we want, because the skin is on, and our mesh is not happy about this translation. So it didn't scale the character because it this isn't going to work by translation only. Or is it? So here's the thing. We have a problem with the Y up already, so we're going to have to, unfortunately, export the skin weights and re-import them anyways to fix that problem. Because unfortunately, the person who wrote the FBX export tools stores the initial bind orientation. I really hope Autodesk does a bit of a cleanup job with skin binding, and because there's now 3 different systems inside of Maya that store the initial bind. Like you have the bind pose that's in here. You have a actual node. Each joint has a node called that has the bind pose on it. There's all kinds of stuff just scattered all over the place from old systems, and I think it's time to clean that up. But right now, what we need to understand is that this is an issue for us because we want to definitely. Actually, you know what? I'm going to get rid of this stuff. I'm going to click on this. I'm going to click on this, and then I'm going to right click and turn them all off. Look at that. Much faster. Okay, so I was just getting rid of the axis because it's kind of get annoying. So what I was saying is now what we're going to do is we're going to save the skin so we can output it, because the last thing you want to do is turn off the skin, change the vertex positions so that they're 100 times bigger. That you want to avoid doing that, because in any other software that wouldn't have been a big deal, but unfortunately there's stuff being stored in the bind pose that is going to cause us some trouble with that. And it's going to add it like a, depending if you have the history on or not, it might add it as another thing that it has to calculate on top. It's bad. You want to be able to get into the stack, what we call the stack, and go before you got the skin. So the cleanest way to do this inside of Maya is to select this, each mesh individually, go into the, not the skin, because there is a thing called export weight maps, and that could technically work, but it's very embarrassing to use. And the reason why I say it's embarrassing, this has been around for over 10 years now, and it's so silly. I would have deleted this a long time ago. What it does is it's going to export the skin weights as individual for each joint. It's going to save an image, a black and white image rendered based on its UV with the values for its skin. It's absolutely abhorrent. It's like, I don't understand why they kept this. This is a horrible system that depends on UVs. You want to avoid this at all costs. You need to go into the menu right next to it called Deform. It's going to have something that will allow you to export weights. I hope Autodesk is listening, because they really need to clean this up. Right now it's a little messy. So right now, if I select this armor, it's detected that it's skin cluster 2, and it detected it, but I can also see it over here as I selected it. It's saying that this mesh has something called skin cluster 2, and it's going to save it as an XML file and not 100 little images with black and white. It's so ridiculous, especially when you see it put it back together. It's like you just get the popcorn and watch the show, and it might not work. So I'm just going to use the proper one and click on this little button here, and I'm going to make sure I'm putting it in the correct folder. I'm going to make sure I've copied that, and I'm going to come over here and paste it. Yep. Okay, so I guess I'm in the correct folder. Yep, I can tell that it's the correct folder. And this time we're going to call it, we're going to call this the armor. I'm just going to call it armor. And it's going to export. And I strongly suggest using the export button and not apply, because you want that window to refresh. All of these little things add up to a lot of frustrations that are avoided. I can tell you that. So you want to watch this video carefully and take note of some of the little things like that, because you might hit the other problems that I'm avoiding by doing these things. So I'm going to click on this now again. It's going to refresh now with skin cluster 1 that I can confirm for the under armor. It's going to be an XML file, and I'm going to click here, and this is going to be underwear. And I'm going to click on export. It's going to create a file with all of that. Great. So now what we're going to do is, now that we've done that, the cleanest thing in Maya to do is to select it and delete its history. You can do a freeze, but we don't need to, because the mesh has no issues with scaling or anything like that. Here, what we're doing is we're just basically stripping away all things skin and anything else that may have been added. And we can do that with the clean button over here and just go delete history. Now we have a very simple mesh with nothing being affected by the bones. So now if I select this node here and I go right click and go scale hierarchy, I'm going to scale it 10 times bigger. So that's good. Now we got to get the mesh to do the same thing. You should be able to do the two at the same time. I'm going to press F8. I'm going to select all the vertices. I'm going to go to to scale. I'm going to double click on the icon here so I can edit where it's going to do that, and I'm going to hold V before I click and drag this. And I'm going to hold that V button so that I can snap to 0, 0, 0. This is so far the best method I've found to do this kind of thing. You're not actually editing the mesh's pivot. This is just a temporary one for modeling, so keep that in mind. We learned this the hard way when we were doing our sushi rigs. I'm not going to go into detail on here. This isn't really where the pivot is. We haven't touched the mesh. It's fine. In fact, that's actually where the pivot should be, but for some reason when we select vertices, it shows it relative to our selection center. Over here, if you don't have this, it should be there. It's the furthest to the right before your name. So it should have a little thing for you to be able to enter values, so we can do this precisely. And then when you press enter, it's going to scale based on whatever transform you're in. It's going to do the thing, and it's going to scale everything perfectly. Now, we need to make sure we understand what we're doing here. The scale of the object is not the same as the scaling tool. When you use the scaling tool, when you're in a component mode, meaning you're editing vertices, when you're scaling it, you're actually just translating the vertice. You're not actually adding, there's no scale value being stored here. So I'm going to press F8 to end, and I'm going to select these meshes one by one just to make sure that what I've just said is not BS. It is not BS. It is true. Scale X, Y, Z is set to 1. And just to make sure everything's clean, everything's good, I'm going to select both meshes and do the clean again, delete history, just in case there's any little tweaks that are stored from doing that. I want to make sure it's been cleaned out because I have history on, so that's why it could have been dangerous. And I'm just going to shut this out. There we go. Okay, now the other thing that we need to do is fix this object. I'm going to turn on its local axis so we can see what's going on. Before we bring in the skin, okay, this is very important. You need to do this before reapplying a skin. If you don't, it will remember that Y is up on the root node when you export the FBX, regardless if it actually has been corrected or not. It's very annoying, so keep that in mind, please. Okay, so to fix this, generally what you do is, and unfortunately, if we were to go into rotate mode, and I was to use this tool and say preserve children, I know from years and years of exporting stuff with Y and Z up issues, I know exactly what value needs to be put in. It's -90 on the X-axis. That will flip the Z and the Y-axis. So if I do -90 here, it's going to do it, but unfortunately the preserve children does not include actually entering values here. So you could use a snap or whatever, but I'm going to show you another method very quickly. You take the next, like here we go, in the hierarchy, we have root, and we have pelvis. Pelvis is the only thing that's attached to the root, so this should be easy. You select the pelvis, you press Shift P, P for parenting, and it basically now it is back to it's exactly where it is. It did not change. This thing now is available to us, so we can do -90, and that's fine now. Z points up. That's what we need for Unreal to be happy. And now we need to get the pelvis. And I'm going to press Q to make it easier to select stuff, and then Shift select the root. And then I'm going to press P. And now we've got our hierarchy fixed. So this is still, preserve children should be off. Man, it didn't help us at all, huh? Okay, so now we have what we're expecting as behavior with the Z up, and we've effectively fixed everything related to scale. Now we just need to get our skin back. So this is something I'm going to do very slowly and carefully. First, select, we did the armor first, so we'll do it again. I'm going to shift select the root node, and I'm going to use the hierarchy. This is a good method that I suggest you use so that the order in which bones get added to a skin is the same. This will save you some headaches, believe me. So if you go into skin and go to the bind skin, we're going to go into the options because we need to make sure we have nothing sophisticated like the voxel or the heat maps or anything like that. We want to use the most basic skin possible that will be compatible with the data that's going to be coming in. So joint hierarchy is what I was just talking about. So basically we selected the mesh and then the first joint in our skeleton and the grandparent node. And what it's going to do is it's going to use the rest of the hierarchy for the skin automatically using joint hierarchy. You can make it so that it's selected joints, so you could have a selection set and deal with it that way. But I suggest very strongly in this case, in this kind of scenario where you're bringing it back in, to use the exact same method that you used originally. And if you can't remember, that becomes a problem. So generally, I use this, especially when you're dealing with a scene that could possibly be a reference. So I'm going to do joint hierarchy. For the bind method, we just want to make sure it's very simple. The closest distance is like the default in Maya, the old default. It's going to do classic linear. I'm not going to go into details on that. I've got videos talking about that. Normalized weights, I'm going to leave it to interactive. Weight distribution is going to be based on distance. I'm going to set my max influence to 4. Just know that when you're dealing with real time, the more you have here, the worse it gets for calculations. In fact, up until recently, we could never go beyond 4. I remember how hard it was to get up to 6 for facial animation. Later on, that becomes an issue. So we need to just be aware of it, and we set it to 4. Maintain maximum influences, meaning no more than 4. Unused influences, we don't have it. It's okay. Unreal's going to do a good job about this. And this colorize, we don't really care. Deformer node is going to go to skin cluster, and we're going to go apply. Okay, I'm going to close this because sometimes these things. So my skin cluster 1 this time is here. And this time the under armor will be the number 2. So I'm just showing you that shouldn't cause you any trouble. I'm going to click on skin again. I'm going to go to bind skin. And in this case, because I have everything set up correctly already and there's nothing to change, I'm just going to click it. And it should set up the skin so that it has a horrible skin weight by default. Okay, but at least it makes sense why it's doing that. I mean, this is not bad for a starting point, and then you could fix it, but there are better methods that I've gone over in other videos. Okay, so it doesn't matter because we're going to get rid of it in just a second. So I'm going to select the armor, and then I'm going to go into deform, not the one in skin, the one in deform, and I'm going to go import weights. And it's auto-detected that this is skin cluster 1. I'm going to click on this little folder thing, and we know it's the armor. And mapping method, it's going to use the index. And we've turned off the ignore names. It's not, by default, this should be like this. You should have the same thing I do. So basically, if it can't find things based on the order, it will use the names of the bones to be able to figure out what weight goes to what. This can be this can save you. So we're going to go import. And now we're going to take a look and see if the armor is coherent. So that kind of is the same kind of effect. This seems like it's working. So if I rotate this, yeah, for the most part, we've got our rough skin back. And I'm going to select this one, and I'm going to see if this works too. I'm going to go to import weights, and I'm just going to click on here, and this is going to be its underwear. And we're going to leave everything the way it was and click on import, let the window close when it's done. And now we should have exactly the same thing we had before, which was already pretty sketchy, but it's a little dodgy, but it's okay. It'll do what we need to do for today. And we now have a character that has been fixed. So I'm going to save this because it's a good idea to save. That was the file that I opened before from a previous attempt at this video. There's always something there's always a video, there's always a phone call or something that interferes. Okay, so we've saved it. Now what we're going to do is we're going to export this and then do exactly what we did before and see what happens when we import this. So I'm going to go to export all, and I'm going to for the sake of argument, I'm going to call it something else, and we're going to export it. We're going to import it differently. 10x. So it means it's a stormtrooper, but now it's 10 times bigger. I'm going to keep all my options the same, and it's going to be like that. Now, I could use the re-import, but when we import it, the reason why I'm doing this separately is because I don't want to just update the thing that we had before, because it created a physical asset based on the proportions that were, so there's going to be remnant stuff that's not going to help us. So I'm going to go back to Unreal here, and I've got my folder here. So I've got my 10x, boop, and I'm going to go to this this little window. And for the skeleton, We're going to use the one that was in Unreal. Just scroll over, you'll see which one it is. You can create your own skeleton. It should work as well. Import. So by importing it, you'll see that it created a physical asset. What is a physical asset? It's basically, think of it as for the majority of the joints that are in your skeleton, it will, for the bigger ones, it will add a volume to it, and then that will become the thing that it uses for hit detection. So if you shoot the stormtrooper later on in the game, in your game or whatever it is that you're working on, it will be able to detect which bone got hit by your bullet or your laser or blaster in this case. And we can take a look at it real quick. If you double click it, it'll show you the file, and it'll show you all of the volumes that it created. This will eventually, we need to tweak it as well if we want to have ragdoll that makes any sense. So for now, we don't care. This thing obviously was too small, so let's see what our 10x friend looks like. This looks more like what we had before. It's hard to tell because it's Unreal is zooming in on it, and we can't really tell what the scale of it is actually. But now if we go to the third-person character, and we have our 10x here selected, we should be able to plug that in now. So okay, so we're getting somewhere. This looks already a lot better. So if I were to look at meshes and just for the sake of argument, it was this one here, SKM Quinn Simple. If I click on it, now it makes a lot more sense. This looks more like what we were dealing with, but will it do all the weird stuff? It's got an interesting pose for a stormtrooper. Oh, let me undo that, hopefully. There we go. Sometimes the Alt key doesn't get held down. Okay, so this might look a little distorted because of the perspective. So let me move that into place, and there we go. So that's what it looks like. And over here, in this case, I'm just going to bring that so that we can see what we're doing on a little bit better window. I know it's not easy. It's a one screen, so I'm trying to make it so that it works for the majority of what we're doing. So if I click here, now we have a stormtrooper. If I press forward, oh, I gotta click in the screen. It always gets me. So if we push forward, well, he's doing the shuffle, which is kind of weird, but we're going to solve it. And the reason why it's doing the shuffle, and this is the difference between Unreal 4 and Unreal 5, is those nodes that I mentioned before for IK. So right now, it doesn't know where its IK is, so it can't activate it. So it can't actually bring in the IK motion and detect where the floor is and make the foot touch the surface properly. So, but for now, where we've already fixed the problem where it was doing kind of like that slap down, like a fly swatter thing. The reason why that was happening was because as we pushed forward, it would use the up axis, in our case Y, to determine in what direction up is. And so to move forward, it was using the Z axis, which was not pointing in the right direction. So it wouldn't know how to make it move forward correctly. We made sure we changed it before we added the skin, so no problems. If you're having problems, it's probably because of the order in which you did things. So now we're going to fix the all things with the legs. We exported the other one, so we should be able to use that as a point of reference. So I'm going to press escape, and I'm just going to bring that over here. Make our life easier for when we come back. Now in Maya, we've saved this, right? I'm just going to save it again, and then I'm going to import, import, and I'm going to put it to FBX. And let's see, is this the correct? Yeah. So SKM Mani Simple is what we exported before, right? We took the mesh and we did an export. If you forgot what that was, it's very simple. We go to a mesh like the Unreal mannequin up here, and man, it's tough. I can get rid of the filters maybe. There we go. At least the filters are not taking up a whole row. If I go to meshes, and we look at what was there originally, the original mesh also had the correct things for IK. So we're going to see if we can just bring those in and solve our little problem. If we go to the mannequin here, this is the mesh that we're using as a point of reference. This is the Unreal 4 mannequin. This is what our skeleton is based on. You're going to notice that it has these nodes that are grayed out right now. But if you click on these nodes, you're going to see that it's pointing to where the feet are. It's pointing where the hands are for it to use for IK. So when it's going to do a real-time solve of the IK, it needs these objects in their initial position, so it's the correct scale and everything. And that can only be done on export. And unfortunately, the FBX exporter also looks at the point of binding. So if you ever have any problems with this and you're having trouble updating it, just export your skin again, bring it back in with all the changes that you made, and it will update the bind information for the export in the FBX. It's a lot of little things like this that really add up. Over the years, you'll get used to this. For now, we're in a state where, unfortunately, the how we export things has a lot of gotchas, but I'm showing you them, so at least you're going to be able to navigate through this. So over here, this is the file that we exported, right? By simply going to by selecting the skeleton, right-clicking on it, going onto the asset actions, and going export, and we brought the FBX out of Unreal, not into Unreal. So I'm going to just bring this guy in, and I'm going to make sure that I'm adding and updating the animation. Add and update animation. So it's not going to take what's already there and adjust it. That's the important part here. And it's not going to ignore the mesh and just go with the animation. I want to make sure it adds and updates animation. So that means it's going to bring in a new skeleton and everything else. And it's not going to touch what we already have in our scene. So I'll just give it a second. Okay, so we already see that there's a little bit of an issue here. Yep. So, okay, so what's important here is it is using the same root node. So if we look over here, we got SKM Manny Simple. This is the mesh, right? And it's okay when we have these little problems. Rotate -90 should solve all of our problems. All right, so just to be clear, because it unfortunately didn't just add it, it actually moved all of our vertices. What I'm going to do is it moved all of our joints, even though I specifically told it to add it and not just modify the ones that are there. We're going to go new scene, and these kind of problems I don't edit them out. Like I mentioned, these are, if it happens to me, probably you're going to want to see this yourself. So I'm going to import, because I did this a little differently when I was doing some different runs of the video. So if I look here and I go, boop. Well, this is the other one that is there, so it doesn't matter. It's going to give us what we needed, anyways. And if I look here, you're going to notice that this is the SK Manny Simple. So this is the one that's in Unreal. That's the newer one for Unreal 5. It doesn't matter you're going to notice that it's almost identical. It's the same naming convention, same orientation, but it has more nodes. And if I minimize, if I make the pelvis smaller, you'll see that we have all the things what we're looking for. These are very handy things to have. And we're going to keep basically all of these. We're going to bring those into our other skeleton. We're going to make sure we match up the correct joints to the correct parts. And we're going to kind of like do a graph of grafting of the two skeletons. Now, one of the other things that I'm glad that we opened this file, because you may have noticed that the FBX importer, if we were to export this as is, this being an FBX file that was exported from Unreal, if I were to bring it into Maya and then export it again, it's going to export a new node that wasn't there originally. And it's going to break the rig if you do that, because you'll notice that this is trying to solve the Y up and the Z up issue by putting a -90 in the X, and it added an extra node, and that's bad. So in this case, what I'm going to do now is I'm going to take I'm going to take this guy. I'm going to delete it. Right. I'm going to delete the mesh as well. Hopefully Maya doesn't crash on me. Ooh, looks like Maya's having a little tough time there. Okay, so I'm going to delete the meshes. I'm just going to keep this. Also, I'm going to do Shift P. I'm going to get rid of this mesh here. That's this other extra root. So I've just been doing some pruning here. So you should see that it's exactly the same as what it was by doing that. All I did was unparent the root and then delete that extra node that was there. And I got rid of all the stuff that we're going to need for our character. In fact, the root as well is like we saw before when we imported, it may update the current one that's in our scene. So we may not want to have this. So what we're going to do is we're going to select all of these, right? And press Shift P. It will maintain all of its sub things. It's fine. All of its sub nodes are fine. I'm going to delete the root node. We don't have any of these in our scene. So this is what we're going to need to have. So all I'm going to do is I'm going to save this, save scene as, and I'm going to call this IK nodes. Okay, now I'm going to open my the one that was clean. Okay, good. And then I'm going to do a file import, and this time I'm going to switch it from FBX to Maya scenes. And I should be able to click on this. This is going to be different now. And we have new options. And it's going to add, I don't want it to use namespaces. Well, we'll see if it's going to add. Let's see if it added it. Yeah, it added it. So let's say if I go into, actually I have it right here. I can right click here and go into namespace editor. It added the IK nodes name to it. And also did not create, it didn't create the namespace because I told it not to, but I didn't want it to rename all the things. So these are problems that happen all the time. So we're just going to go, yeah, don't save. I'm going to go import. I'm going to redo that. This time I'm going to use the namespace with its silly thing. And it's going to add the namespaces correctly, and now I can get rid of it. Hey, these are like I'm used to other softwares. Each software has its little quirks. This is one of them. So we're going to go into namespace editor, and we should see the IK nodes. And all I'm going to do is collapse it to collapse to child. Well, actually, sorry. Got this guy. I want to collapse it to. Yeah, I want to delete it. So delete and merge with parent. There we go. That's what I wanted. So now it's gotten rid of the names and it's kept it the way it should be. Now if I do this kind of thing, select all of these. Make sure you're not seeing any sub objects when you're shift selecting this, because if not, you'll be selecting also all the sub objects and you're going to break the hierarchy. So I'm just selecting these, which are the first of each hierarchy. In this case, they don't have children. And if you control click on root, that'll be the last one. If I press P, it will correctly do this, where now I've added the IK foot root with IK foot left, IK foot right, correctly placed. So now we're just going to do some matching. So to make sure that it matches our skeleton here. So what I would suggest you do is do everything in order. So let me just see some gizmo. Okay, so that we don't need to touch. This one we definitely need to touch. We need it to go to where this one is. And you just go match translation and rotation. Boop. Goes into the right place. We're going to go down the list. I'm going to shift select this one. I'm going to go match translation and rotation. Sorry, buddy. We'll hang out later in just a little bit. I'm just talking to my cat. Sorry. All right. So what's next is we've got the IK hand root. And there's a lot of things going on here. So the first one is fine. Go down the hierarchy so we don't actually have to do this over again. And then we're going to shift select this and go match translation and rotation. The left hand is going to need to match with the left hand. And then the right hand, will match with this one. Maybe that one might not be a problem, but just in case, I'll just match it. It seems to be fine. The interaction node seems to be at 0, 0, so we don't need to worry about that. And the center of mass is also at 0, 0. That's not where the center of mass should be, but anyways, for the purpose of how the skeleton mesh is expected by Unreal, this is the correct setup. Now we have these extra nodes that have been added. We can go File, Save Scene As, Clean again. We'll just go right over that one. Okay, so now we're just going to go File, Export. In this case, we can just go over the last one because we're going to re-import it. There's no problem with scales or anything like that. So with this, everything could go wrong. So in this case, it's pretty safe to do that. And if we go to the Stormtrooper where we had him, the Stormtrooper 10X, you can right-click and go re-import. And it should re-import it and find those nodes that we just added. So if we look here and double-click it, sure enough, it found the nodes that we added. Now, if we, let's say we try to run it, I'm already seeing that the standing differently. Yes, so we're good. So we've solved that part. I know it looks like a lot of steps and a lot of things to deal with, but believe it or not, once you've done this procedure a couple of times, it becomes quite natural. And whenever you see a problem, you're like, oh, it's that thing. Oh, it's the Y up. Oh, it's the fill in the blank, that all the things we did to get it going here. Now, the last thing we're going to do is we're going to create some materials for our Stormtrooper so that he looks correct. And so I find that that's a good way of showing you how to import a model. You could import your textures and so on. But what I'm going to do is I'm going to click Escape here. You're going to see that the mannequins have a little material section. And all I'm going to do is I'm going to create a subfolder here, if I can, at the Wacom. By the way, I use a Wacom tablet for any of you that have wrist issues or carpal tunnel. I've been using the Wacom tablet for many years. It's a bit of a pain when dealing with things like Unreal, but it's not a pain in my wrist. So at least you might have these little weird things where I'm trying to right-click and I'm having trouble. These are Wacom issues, but don't blame Unreal, don't blame Maya. So sometimes I'll switch to a mouse in case I need some precision. So we've created I'm going to use the mouse for this one, new folder. And I'm going to call this one Strom. I do that all the time. Stormtrooper. Okay. So I created the Stormtrooper folder inside of materials, specifically just for it. And I'm not going to worry about the instances and all that stuff, because I'm just going to put the stuff that we need in here. You can reorganize it however you want. Just know that what I'm going to do is I'm going to create, so if you're not very familiar with materials, and shaders and stuff like that, because that's a whole other subject. I'm going to show you how to create what we call a kind of like a root material. There's other terms that we can use for that. Basically, it's a kind of like a parent material. That's another one that I've heard as well. So you can right click in here and go new material. Okay, and I'm going to call this one Matt. Well. Okay, so let's just keep it simple. Matt Stormtrooper. Actually, we're going to put it like this. This will be easier to understand, because when we make an instance, it'll put an underscore inst at the end of it. So it'll be easier to understand that this is the base material or the parent material. And you could also just say parent Stormtrooper material. In fact, that will be... like, use whatever naming convention you want that makes it clear to you. My suggestion to you is, once you've determined this convention, stick to it. Do not change it, or else you're just making your life infinitely worse. Okay, so I'm just going to call this parent Stormtrooper Matt. That way, now I'm just going to double click this and see what kind of material this is. This is basically a default material. And you have things like color, specular, roughness. If you haven't done materials before, know that these three here are the most important aside from color. for how reflective and how shiny or how it can, because there's different kinds of things. Like, think of it like a mirror reflection, and then there's a shininess. They're two different things. So anyways, we're going to go into how the light is going to react to the material and also its base color. So I'm going to hold down the 3 button, like the on the keyboard. I'm pressing 3 and I'm holding it, and then I'm going to click, and it's going to create, because I don't even know how to do this anymore. I've been doing it for so many years that I use all the shortcuts, and they're not really all that complicated. I wanted something that has 3 values, and I just hold 3 and then click. And you guessed it, if I want a single value, you hold 1 and you click, and it'll create a single value that we can use. So this thing is what's going to be our color. Okay, and just for the sake of argument, I'm going to make it red. So for example here, I'm going to make it red. Go OK. And now we have a red ball. And you'll see this will get better for the updates once we set this up. And while we're at it, because this is going to be our parent material, we're going to be making instances of this material, meaning we won't have this level of control where we can create nodes and figure out the logic on how it creates a color, but we are going to be setting some things in our parent material that we can modify in our instances. So for example, the base color, we can right click it and say convert to a parameter. What that means is this now will be something that we can modify in the instances. If we were to make an instance of this material to create, I don't know, like let's say something on his belt, or the white part of the armor or the black part of the armor, and we want to change its color, until we make it a parameter, we can't modify that in the instances. So I'm going to call this base color. Very original. Very, very original. Actually, I didn't even use the exact same naming, like use underscores. Try not to use spaces. This isn't a Mac. Okay, so we're going to put underscore color. And now this is something that we can easily change in our in all the different versions, because we're going to use the same parent material for the white, the black, and the shiny parts. All those materials that we saw in the list when we imported. We didn't. I didn't go over it yet, but we're going to be replacing the materials that we have in Unreal. And the other thing that we're going to do is going to make sure that this is 2-sided. Because when we were running around, I could see through the helmet. Just put it to 2-sided. This is not great for rendering, and normally there are other methods that can improve this, but for now, we're just going to leave it 2-sided for our base material. This is also where we're going to bring in the metallic. So if you, for metallic, let's leave it at, I think the default is 0.2, if I'm not mistaken. And we're going to turn that into a parameter as well. We're going to call this metallic. And I'm going to press 1 again. And oh, look, the defaults are here. Okay, so my bad. 0.5 specular. Convert that into a parameter. We're going to call that specular. In a moment, you're going to see what we're doing here. Press 1. And these materials get more complicated with the more features and things that you want to do with the normal maps and all that stuff. So I'm going to convert this into a parameter, and this guy's going to be the roughness. And the default roughness is 0.5. And I'm just going to connect that there. And I think we're pretty much done with our parent Stormtrooper material. So I'm going to click on Save. And that should apply it as well. So now we have this. Now what you can do is you can right click it and you say create material instance. And the material instance will, it's just like I mentioned before, I'm going to get rid of the word parent. Stormtrooper material instance. And we're going to give this a name. So Stormtrooper underscore black for the black material. Actually, we're going to have a black material that's shiny and another one that's more matted for the Under Armour. So we're going to call this one, or when people think of a Stormtrooper, they think of the white armor first. Okay, so the white material. So we're going to do that. Now when we double click this, it's only going to have what we put in here as options. Remember, like I mentioned, this is the only thing that we can actually change now. So if we want to, we can go and click on these things, which will override the default value that we put in the parent. And now we can go in here and make it white. And yeah, so we'll just leave it up to white. And let's see, for roughness and this, maybe let's make the white part a little bit shiny. Something like that ought to do it. Maybe a little tiny bit more metallic, just a tiny bit. Okay, so that's good. I'm happy with this. We're not gonna mess around with it too much. I'm going to right click again and go create material instance. Get rid of the word parent, and we have Stormtrooper, and then we're gonna have a name. So let's say shiny. This time I spelled it shiny, not shinny. That's good. I'm going to double click that. And now I'm going to go back again into the global. We can create structures for this. There's a lot you can do with this to make it easier to use. So this is going to be definitely black. And this is the shiny bit. So these are like the little things that are, we're going to want to, yeah, higher metallic here. For this is going to be like the reflectivity type of thing. Here we can make it really reflective. And you can notice the specular highlight. It was changing. So this is very shiny. This is very metallic-y. Maybe a little too metallic-y. It's going to look like a mirror if I'm not careful. Did I make it worse? Okay, so for roughness, I think 0.3. Ooh, 0.2. Yeah, I want it to be somewhat reflective and shiny. Okay. All right, so we've got this guy. You can make a duplicate of it just by clicking it and going duplicate. And here we're going to name it matted. And the matted one is going to be the same thing. It has all of our options. It's got the color and everything. In this case, we're going to go really rough, so 0.8. And just that alone should be just fine for the under armor, the stuff that's underneath the armor. We don't want it to be shiny. We want it to be as flat as possible. So that's good. So we've got materials now. Now what you want to do is, if you still have it up here, you can go to the mesh that you were working on. Aha, this is the one. This is definitely, if I go over that, Stormtrooper 10X. Okay. So what you're going to notice is that it has the material slots. When we exported from Maya, it used whatever materials were applied to organize which is which. And to know which one it is, click on the isolate button. So here we've isolated what triangles are related to the first material slot, and it's the under armor. So we know it's this guy. And if I click here, oh, there we go. Just takes a minute. We've applied it on the under armor. If I go to the next isolate, this is the shiny white part. So I'm going to put it. Let's see here. What are you? You are the shiny black parts. So that's good. Now, what do we have here? We have some other shiny. Maybe these you might want to keep them as matted, and we're going to do that. And also, whenever you're working on this stuff, you can go. Actually, you can just go. Go to Maya, apparently. You can go to File, Save All. And it'll save all the things that you've done. And now we have ourselves a nice Stormtrooper. So I'm going to, we're going to just take a look real quick over here if it's working. And we have ourselves, let me click on the viewport. And we have our Stormtrooper all set up. Now, now is where you can actually get creative if you want to. So if I press Shift F1, it'll pop out my mouse, and the game's still running. I could double click on this, and I can make changes live. Because it's a material with all these parameters set up, it won't have any problem with that. So let's say I've been itching to do this. So we can see I want a pink Stormtrooper. I bet you they're the most badass Stormtroopers that there is, and I'm going to make it a lot more reflective and shiny. There we go. Now we're talking. This is a Stormtrooper that brings fear into people's, like, now if I'm running around with this character, oh yeah, this is awesome. Okay, so our skin needs a little bit of work, obviously. There's a couple of things that don't look so great. If I press F11, can I? Yeah. And I'm going to press Shift F1 to say to close this. And I'm going to click back in here. So we've gone from Maya with all the issues that we had for scales and for alignment and so on. Yeah, so there's a lot of caveats, a lot of issues with bringing things from Maya, but we went through all of them. You have the tools now to be able to figure out how to fix this. And I strongly suggest just bringing in your characters from Maya, see how they look before you do any rigging. Always consider doing the skeletal mesh just like in Unreal, and that way you can see what it's going to look like in Unreal. Focus on Unreal when you're dealing with your materials, because you want to see the end look. And this is so far so good. So I hope you enjoyed this video as well as found it informative. But that's it. So we've done everything we said we were going to do, and everything is functioning just fine. All right.